I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics,
medicine,
nature,
Space. Time.
brain,
Life. The universe.
Today on The Naked Scientists, we've gathered the brightest and the brainiest to answer your science questions.
So if you've ever wondered whether fish fart, now's the time to find out. I'm Chris Smith, she's Kat Arney, and you're listening to The Naked Scientists.
The Naked Scientists podcast is powered by ukfast.co.uk.
So let's meet our suite of scientists. Today we have with us Matt Middleton. He's an astronomer from Cambridge University. We have Eleanor Drinkwater. She's an animal behaviourist. I assume that doesn't mean she behaves like an animal. She's looking very quiet right now. Give us a roar. Also from Cambridge University. And we have Giles Yeo from the MRC Metabolic Diseases Unit, who can take on your questions about diet and nutrition. And of course, there's Chris Smith, who knows everything, and me, who knows some stuff about genetics and stuff.
You mentioned Giles. Giles, this one is for you. Frank got in touch and he said this.
last year, I heard this ridiculous dieting tip of shivering for 10 minutes. Is there any advantage, calorie-wise, in eating all meals frozen?
So, can you shiver yourself slim?
I think the answer is going to be it's probably not a good idea to have your meals frozen. Saying that, though, clearly, if you shiver, you are using calories and you're using energy. But you can do that doing any other. It's probably easier to go for a walk. It's easier to do any number of things. I would recommend eating your food warm.
So my housemate yesterday morning walked in holding a stick of celery and said, I'm detoxing. I'm going to do a detox. I'm just hardly going to eat anything. And by lunchtime, she'd cracked and was eating lunch. Do a lot of people just start off with all these good
What did she
intentions? She just cooked up, I think, with some like chicken and some vegetables. It was quite healthy.
Not ice cream, because then you could, I think, are they not looking for a bit of a get out clause? Because they could say it's cold, so I'm actually having to make a lot of energy to warm this up. So therefore, it doesn't
Is
count.
ice cream a health food? Make our day.
I am not paid by Haagen-Dazs or Ben & Jerry's. Other ice creams are available.
Ice cream, not a health food,
So
I take
basically,
it.
Giles Yeo, it's a no from you on that one then.
It's a no from me. No,
Okay.
I think it's like saying that. Well, it's better to drink water cold. Some people says well, it's better to drink water warm because you're warm and it's better than. Look, we are very well temperature controlled all the way through. It's the same thing as having a pH diet. Once again, we're also very well controlled on the pH front. Just eat healthily.
Eat healthily and do exercise.
Absolutely.
Thanks, Giles.
So I guess speaking about an animal that could be food, here's a question for you, Eleanor, from Josephine.
I have two mallard ducks that come to my patio. One comes up to the door wall and keeps tapping on the window. Why is this?
What do you reckon?
Well, it's a really difficult thing to say without seeing the ducks themselves. But I'd say it could be down to two things. One, if there was a nice reflection of a duck on the other side, ducks can't recognise their own reflection. The only bird known to recognise their own reflection is actually magpies, so it could be thinking there's another duck there. Alternatively, if you've ever fed it before, it could be coming back to try and check out the scope and try and persuade you to feed it something else.
Has anyone noticed this with ducks? Anyone got ducks in their garden?
Ducks with crows. I was asking you, I think, before we came in here, whether it's the same reason as with crows, because we had this crow on the top of our house once, just tapping at the window. We had to put these little spiky things up to stop them from actually coming in.
I think Eleanor's point about the reflection is the one, because our next door neighbour has a window that at certain times of the day reflects the sun, and the birds sit on the windowsill and tap on that round window. And I think if you look, I can see a reflected bird sitting there, and I think they probably catch sight of themselves as they go past, because birds have got fiercely good vision, haven't they, Eleanor?
Yeah.
And so they're probably trying to attack this predator that's invading their patch.
And then there's also the reverse problem, isn't there? Because my mum has big patio doors, and before she put some big stickers of birds on them because she used to get poor little things just flying straight into the glass because they couldn't see it. Is that quite a big problem too?
Yeah, birds flying into windows is a really big problem. And in fact, there's some really cool research that's going on in order to... Birds can see in UV, whereas we can't. So there's some really cool research going in to kind of put some stripes across the windows and all sorts of different things to make marks that the birds can see that we can't.
Oh, wow. So you could have like a scary UV bird that instead of obscuring your vision with a sticker.
Yeah, well, that's the idea.
I think the duck was just quackers.
That's the other alternative.
Now, Matt, you've been very, very quiet, so we're not going to let you off the hook. Dylan got in touch.
Hi, I'm a huge fan of your show, and I have a question for you. So, if two black holes collide, and there is a ripple of time in space, what would happen if you flew through it? And what other situations can change time itself?
Now, this happens on Star Trek a lot, so I'm really interested to hear the answer to this.
What?
People flying through
A gravitational wave?
An anomaly in the space-time continuum.
Okay,
Happens
right.
a lot. And Jean-Luc Picard's hand went all funny in a fruit dish once. And I always wondered how one would argue that from a physics point of view.
Well, I think we've identified the Trekkies in the room here. So what
Singular.
happens?
Singular. Okay, so obviously a very pertinent question, given that LIGO has directly detected gravitational waves.
LIGO?
LIGO is the
It's the gravitational wave.
It is
detector.
Laser Interferometer Gravitational Wave Observatory.
Right.
And they detect gravitational waves for the first time. And these are formed when black holes merge. They can be formed in other ways too, but that's what's been discovered from LIGO. So these waves, they propagate outwards, and then they're crashing through us all the time. Right now, gravitational waves are going through us. We don't feel them because
I went to the curry house last night, and I think I've had one or two gravitational waves afterwards.
Oh, that's beautiful. What a lovely image. The strength of gravitational waves falls away inversely with distance. And because these things are astrophysical in origin, the gravitational waves that cross us are very, very weak. In fact, LIGO had to detect, essentially, the sun moving by the width of a human hair. That's how accurately they had to do their measurements. That's absolutely phenomenal. But what essentially happened, though, is that if you had two particles together and a gravitational wave goes through them, they'd be pulled apart and compressed at the frequency of that wave. Okay, so it'd be like a tidal force, like when the moon goes around the Earth, so it pulls and pushes, stuff like that. So in terms of time, though, the effect is extremely minimal.
But does it actually do anything different to your body? Does that mean that literally parts of your body are experiencing time slightly differently as the wave goes through you?
Time, probably not. The time dilation effects are going to be extremely minimal, but in a physical way, you'd feel a tug. It'd be like a tidal force. So as if you
But
were
a very small one.
very,
presumably.
very small for us. If you got very close to the black hole, then there'd be a huge tidal force, but then your day is about to get much, much worse. Because I don't know if that was on Star Trek. Yeah, right. And then you are in a seriously different realm of time dilation effects.
In serious trouble. Chris, here's a question for you from our listener Stephen, who's asked, we've heard a lot about the Zika virus in the news, and obviously particularly with the Olympics starting in Rio and Zika in Brazil is a big concern. He wants to know, is it a risk to pregnant women? We've heard that it is, but how long does the virus remain active for women who might become pregnant in the future? For example, is this something for a woman to be concerned about if she catches the virus today and is thinking about becoming pregnant in, say, 5 years? Or does the body get rid of the infection? And what about for men who might be carrying it?
Yeah, these are all really pertinent questions which we don't actually have gold standard answers to yet, but it is a big problem, and based on the paper from Andy Tatum's group at Southampton last week in Nature Microbiology, they're saying that 93 million people are going to get infected with Zika in the next 2 years in the Americas, and there will be 1.5 million women who are currently bearing children in that group of individuals. So there's going to be a lot of exposures going on. And those are people who catch it when they are pregnant. Now, we know that's a risk because when you have virus in your bloodstream, it can get across the placenta, which is normally a very good barrier, and stop it getting in. But with this virus, it can cross the placenta and it homes in on the stem cells that make your brain, as well as other tissues, and it damages those stem cells. So that's why it causes harm to a developing baby. The thing people are really worried about is whether or not it can lurk in the body and stay there so that although you've cleared the virus, you could succumb later or your pregnancy could be harmed. The evidence is that if you're female, you catch Zika, your immune system kicks in, it kicks it out, and you clear it after a week or so, and you do not have any virus that's going to cause a subsequent pregnancy, any problems, because it would have to get across the placenta from the blood, and there's no virus in the blood. Where the threat comes from is that your partner could, if he catches Zika virus, retain virus in certain body fluids for an extended period of time. We know that there have been sexually transmitted cases of Zika anything up to several weeks after the person stopped having any symptoms or any virus in their bloodstream. So the worry is people could think that they're actually fit and healthy and they've recovered from it, or they may not even have had any symptoms of Zika in the first place because 80% of people don't even know they had it, and then you transmit it to your partner. she catches it and she then gets the virus in her bloodstream and it then goes into the baby. We don't think there's any risk of the virus going from the genital tract directly up into a baby.
I think it's probably best just never to have sex again.
Well, I'll leave that one to you, Kat.
To be able to grow, they need to be able to communicate with each other. And so the growth factors are really important because that's how the cells communicate to each other.
In this month's Naked Genetics podcast, we're sifting the signal from the noise. How do molecular signals coordinate cells to build tissues, organs and babies? Plus, big data for big genetics, and our gene of the month is going round in circles. Listen and download now at nakedscientist.com/genetics. You're listening to The Naked Scientists with me, Kat Arney, and Chris Smith. Today we're answering your science questions, so if you'd like to pose one for our next Q&A show, just send them to chris@thenakedscientist.com.
Meanwhile, Kimberly has put pen to paper with this.
Is there such thing as inheritance of obesity or the tendency to become overweight? Could a sudden change in lifestyle trigger a change in genetic expression?
So, Giles, what do you think?
There is definitely inheritance of body weight and body shape. The question, however, appears to assume there's only one inheritance, one inherited possibility, but there isn't. It's not just one gene. It's not just one fat gene. We now know of over 100 genes that are actually involved in determining your body size. The second part of the question about the role of the environment, that's a very good one because our genes haven't changed, certainly over the past 30 years, whereas obesity has skyrocketed. And that is down to the interaction between your genes and the environment. I think the analogy I always use is if two people are standing side by side, they look exactly the same. Suddenly an environment comes along, say me, and I give someone a shove and the other one not a shove, that's it. Someone will fall over and someone won't. And that's because they're interacting with the environment in a different fashion.
In our sort of caveman era, we would have had enormous advantage conferred upon us if we had genes that made us store energy for a rainy day. Whereas now you have Waitrose, Tesco, Sainsbury's, other supermarkets are available just down the street and you can go in there and buy anything you want.
You can do it. It's not only walking in to do it. You can now order anything from your smartphone.
Oh, that's true. Yeah, you can have it delivered to your house, can't you?
Exactly. You don't even have to get your bum out the door, and that's it.
So you can physically be too big to get out the door and you still get fed, which means it becomes maladaptive, doesn't it?
That's correct.
And one of the really fascinating things, I've just been making a radio programme looking at how changes really early on in development affect the health, the lifestyle and even the weight of people much, much further down the line. So there is this important role right at the start of development, maybe even before a woman knows she's pregnant herself, that there could be influences there from the mother. And, maybe if the mother's not got enough food, there's a very famous example of a famine in Holland that were during the Second World War, where the babies were exposed to this famine very, very early on in the womb. And they came out, kind of okay. But then later on in life, they were fatter, maybe because they'd thought, oh, God, we're starving here. We'd better, make the most of everything we've got.
So what you're referring to is known as the Dutch hunger winter. And the field of studying this is in utero programming. And what that studies is when you're actually carrying a baby, is there any programming that happens? And there is. And the reason there is because what you want to do as a fetus is to predict what the environment's going to be and get yourself set up the best way that you're going to be. You got genes which don't change, but if you actually change the markers on the gene, it actually changes the way genes are turned on and genes are turned off. And so there is definitely evidence for that. I have to say, though, that the evidence for the obesity side of things and programming is not huge. The evidence for type 2 diabetes and, insulin resistance and other metabolic diseases, definitely so. And more scarily, people are now beginning to say, before you even become pregnant, is that having an unhealthy diet can actually influence your egg and your sperm. Not together in the same person, clearly, but the egg and your sperm.
It'd be very strange if you did.
in terms. But then there are now studies happening of how can a unhealthy diet or lifestyle influence your egg and your sperm.
There's a question here, 48% happy, at Jemima Bond 007 has tweeted to us, at Naked Scientists, the biggest loser contestants, that's this weight loss programme, contestants suffered issues with metabolic slowdown. Should I worry if I'm following an 8-week VLCD? I'm not sure what I think that's probably
very low calorie diet.
So do you get a change in your metabolism in reflection to what you're eating, Charles?
Well, let me see if I understand the question. I mean, the biggest influence on your metabolic rate is still going to be your size. So the larger you are, the higher your metabolic rate, oddly enough, and the smaller you are, the lower your metabolic rate. So there's that. However, what happens when you lose weight and you lose a lot of weight? Your body, your brain in particular, does not like that. And so what it does is it tries everything it can to stop you from losing weight. And one of the things it does is to slow down ever so slightly your metabolic rate and also increase your food intake to try and make you gain the weight back.
But does that persist indefinitely? So if I lost a lot of weight and I changed my lifestyle, would my brain for the next 55 years still be trying to get me back to the state I was in before I lost weight, or would it slowly adapt and learn that the new slim me was the way I wanted to be?
Well, I'll give you the depressing answer first. The depressing answer, in as far as it has been measured, and you can imagine trying to do that in a human being is pretty tough. But over the experiments that have been done over a couple of years, where they've held someone down at a specific weight after having lost, unfortunately, your brain certainly through that time tries to pull you back up to that weight that you once were.
There's going to be a lot of sorry people out there now, isn't there?
Yeah, I have heard that it's really hard to do these kind of studies because people lose weight and then they just put it back on again. Very sad. Let's move on to a completely different topic. So now, Eleanor, here's a very slippery question for you from our listener, Alyssa, who says, do reptiles show recognition or bonding to their caregivers? If a snake, for example, had a blonde 5'4" and slender caregiver named Anna, sounds lovely, would the snake show preference unilaterally for humans of a similar profile and build? Or would they specifically identify the preference for Anna? So is it the person? Can snakes recognise humans? Do they care about us?
Certainly recognise them when they eat them on the rubber plantations in certain places.
Well, the cool thing about this is no one's ever done any studies on this at all. So I called up one of my friends called Dr. Miller, who's currently in Honduras taming baby jaguars, as one does. And what his view was, first of all, snakes tend to have a terrible sense of eyesight, so they wouldn't be able to tell that Anna was blonde and beautiful. However, they do have this amazing sense of taste. So they kind of stick... Yep, exactly. So they kind of stick their tongues out and they can taste whatever kind of particles are floating around the place. So it's not beyond the bounds of possibility that they could tell Anna from Jacob or Jason or whoever else is hanging around the place. However, the really interesting thing, though, is with a few wonderful exceptions, including iguanas, most reptiles tend to be pretty asocial. They're not like dogs. Like dogs are kind of pack animals and they want to hang out together, whereas snakes don't really care. So the thing is, there's probably no pressure for the snake to form a bond with Anna because there's no real kind of bonding with snakes in the wild.
Now, Kat, this one is for you from John.
I know that humans generally share 99% of our genes. With 25,000 genes, that means we differ by only 250 genes. It seems to me that we cannot possibly differ by the same 250 genes. Thus, my question is, how many genes does a random pair of humans actually share?
This is a great question, but it's sort of based on a misunderstanding because this is a phrase that we often hear that, humans, we share 99% or 99.9% of our genes with each other. And actually, if you took two random humans, there would be 4 million differences in the letters of our DNA, these chemicals called bases. They're like the letters of the alphabet of our DNA. But the key thing is the way that John's phrased this question is like if you imagine our genome as a recipe book that makes all the recipes that our cells need, you're imagining that we would have, say, 250 recipes, whole recipes that were different between us. That's not the case. It's more like there is sort of 0.1% or 4 million differences in single letters, kind of typos, scattered through the whole of this recipe book. And obviously between males and females, people who are genetically male and genetically female, there's a whole chromosome difference. So the two women in this studio, myself and Eleanor, we have 2 X chromosomes, whereas the chaps here, I'm assuming, have an X and a Y chromosome. I haven't karyotyped everyone. I don't know for sure, but that's my assumption. So basically, it's not that we have whole genes that are different. There's this kind of smattering of variations through the whole thing. However, some people do have changes, mutations, variations that do mean that whole genes or even whole chunks of DNA are missing, or even whole bonus chunks. In Down syndrome, you've got a whole extra copy of one of the chromosomes. So there are lots of variations between us, but it's not like saying this whole gene is there, this whole gene is different.
Is it a bit like you used a recipe analogy, Kat? So you're making a cake and it says you've got to have the flour and the eggs and the margarine and the raisins and so on. And rather than getting your raisins from that shop, you've gone and got a different sort of type of raisin. They're still raisins, but they're slightly different raisins. And therefore the recipe you cook up will make a slightly different cake, but it's effectively still a fruit sponge.
Yeah, I mean, or it could be raisins versus sultanas or oranges versus lemons. And actually, just in our own genes, we have a lot of variations. We make, if you think about it in terms of recipes, we make several 100,000 different recipes called proteins that make our cells function, keep us functioning healthily, but we only have about 20 to 25,000 genes. So there's a lot of kind of switching in and switching out anyway. And these tiny, tiny variations scattered between them make us all unique and different.
Thank you, Kat.
So, Matt, here's a question for you from Alan, who has asked, it's not been explained to me why Venus has still got an atmosphere. Mars has lost its atmosphere. It has no magnetosphere. So you could explain that for a start. But Venus is the same. So therefore, it must be restored each time its atmosphere is lost. Let's start with, how does a magnetosphere, a magnetic field around a planet, relate to its atmosphere? And then what's going on with Venus and Mars?
So a magnetosphere is incredibly important. The Earth has one. It has one because we have a molten core that rotates. It generates a magnetic field, a dynamo. And this magnetic field deflects particles that are coming to us from the sun. These highly charged, energetic particles. Now, if we didn't have a magnetosphere, the interaction would start to remove ions from the ionosphere. So our atmosphere would get leaky. Now, Mars doesn't have a magnetosphere. It used to, probably around about 4 billion years ago. We're not entirely clear why it went away. Now, it's not just because it lost its magnetosphere and then everything just, off it went up into space. That's the noise it makes, actually, yeah. But actually, Mars is much smaller than the Earth, and it has a gravitational field of roughly around 36% Earth's. So holding on to stuff is actually very, very difficult. Now, if you go to Venus, I would have to correct one of the things that was said. You're right, it doesn't have a magnetosphere, but it has got something, has an induced magnetosphere because the magnetic field from the sun wraps around it. So it has some protection.
Is that because it's so close to the sun?
Yeah.
Okay, so it's sort of hogging a bit of magnetic field from the sun.
These magnetic fields are slamming into Venus and wrapping around, so you end up with a sort of quasi-magnetosphere.
Like a magnetic cuddle.
A big magnetic cuddle. That is the cutest thing I've ever heard in terms of planetary
astrophysics. And it's holding some gas onto it like an atmosphere.
That's cute. Oh, I'm seeing a brand of toys emerging here. And Venus is very similar to Earth. It's essentially our twin planet. So it's heavy, and that means it holds on to its gas. So that's why it has more of an atmosphere.
Because of the magnetic cuddle.
Because of the magnetic cuddle.
Thank you very much. You are listening to The Naked Scientists with me, Kat Arney.
And with me, Chris Smith. If you'd like to get in touch to ask a question, for instance, you can tweet at Naked Scientists or you can email chris@thenakedscientist.com.
This week, we have a fabulous panel of pundits for you, including Matt Middleton, he's an astronomer from Cambridge University, Giles Yeo, who's an expert in human metabolism, and Eleanor Drinkwater, who is an animal behavioural specialist.
Mark has been in touch, and this is his question. Hello, Mark. Go for it.
All right. I have read that fructose in humans is metabolised to fat and little else. Fructose is readily available in most forms of fruit, form of packaging that arrives in the glut in the autumn. So herbivores and omnivores then have a food source that arrives in huge quantities, encourages overeating, and is metabolized straight to fat just prior to the winter when food is scarce and fat reserves are needed. Could this be the source of maladaptation to modern sweet foods? Are we forever stuck preparing for a time of scarcity that never arrives and shaped by a metabolic pathway that no longer fulfills its intended purpose and instead makes us obese?
If I may, Mark, it is not true that fructose is converted to fat and little else. Undoubtedly, glucose, which is our normal fuel that increases insulin and everything else, that is absorbed by your muscles and by your fat. And that's not true for fructose. It goes largely to the liver where it's actually metabolized there. Only about 1% or so, maybe slightly less, goes directly to fat.
What happens to the other 99%?
It's actually divided between glycogen and actually being converted into glucose in of itself. There is, however, variation in how people handle fructose. Okay, so some people handle fructose slightly better than others, but at the end of the day, all things will be converted into fat if you have too much of it. So in other words, even if you have too much glucose, once your body uses up the glucose it needs to use, it will be converted into fat. The same thing for protein, the same thing for fructose as well.
So does Mark have a point that you have this big glut of fructose at one time in the year and it does end up as fat because effectively animals are taking in more energy than they need, so it favours becoming obese?
But it's not only fructose. I mean, fructose is found largely in fruit, but together with glucose to form sucrose. It's sugar in of itself. Too much of it, when you have it, will be converted into fat. That is the purpose of having that glut where the bears come along and having, the fruit in order to actually get enough energy to hibernate. But that's always going to be true if you have too many calories, in which sucrose is readily available.
Eleanor.
Just quickly from an animally tasty thing, I was reading quite recently about taste perception and, why is sweet things tasty? And from looking at birds, it seems to be that it evolved to teach them, this has lots of calories, therefore it's worth eating, therefore it's sweet. So that's the kind of evolutionary thing. Is it the same in people, do you think? Or do you think it's a bit more kind of complex than that?
No, I think it probably is quite that simple. So sugar is one of the most energy-dense things we can have per gram because you get 100% of the calories from it and you eat it. And interestingly, if you actually take babies, they can take food that is sweet, that is incredibly sweet, that we would find inedible. But babies will go, delicious, yummy. And then what happens is as they get out of babyhood into childhood, then into our age, when our palate becomes adult-like, we can't take food that is as sweet than as our kids can. And if you actually taste anything the kids eat, oh my God. And so I think it's quite that simple, yes.
Wasn't it you who said once, Kat, I love babies, but I couldn't eat a whole one?
I think they're sweet, but too sweet for me.
Now, Eleanor, we got this question for you. You're not off the hook yet.
Do fishes fart? For some strange reason, this thought came to mind while I was in my bath. As a physician, I know that human flatulence comes from two sources: swallowed air or gases produced during digestion. Since fish can't swallow air, perhaps their digestion also produces gases?
That was John, by the way, who was in his bath when he conceived that question.
I think this is a fantastic question. I absolutely love this question. And I can say categorically that some fish do fart. In fact, a recent study discovered for the first time that herringfish produce fart noises, which they think they use for communication.
Herrings talk to each other by farting at them.
Apparently, they discovered that if they put more and more fish into a tank together, the increase in fart noises would increase disproportionately to the number of fish.
When you say fart noises, do you literally mean as in farting noises?
Well, yes. It's a small jet of air which comes out of the anus.
Where do they get the air from? Because as is pointed out in the question, fish don't breathe air. And when we swallow air, some of it emerges at the back end and the bugs in our gut metabolise some of it to gas. So where do the fish get theirs?
Different fish are kind of put together differently. In the case of herringfish, they have their swim bladder, which is a little sac of air that helps them kind of buoyancy around the place under the sea, is attached to their gut, and they can actually gulp air in from the surface, and they do produce a little bit of gases themselves, which then go from there into the swim bladder. If the swim bladder gets too full or they want to change depth, they can then spit some of the water back out. So yeah, that's where the herring get their farts from.
So it is true then.
I just think that's amazing. I've just been home to see my parents, and I think the dog was trying to tell me something. And moving to a slightly related question, but in the human realm, we have a question here for you, Chris, from Kitty Matze, who's written in for some medical help.
Please help. I'm forever constipated. I exercise at least 3 times a week. I drink lots of water. I eat all bran almost every morning. I don't eat white bread. The feeling of wanting to do number 2 never comes naturally. Why and what can I do to help it?
That sounds uncomfortable.
It sounds uncomfortable, doesn't it? Well, look, this is actually a pretty common, so I thought we could have a little quiz, because actually you might think that this is something that only everyone else suffers from, but in fact many people do get constipated, and I thought we could have a sort of science fact or science fiction around constipation, or in this case, I suppose we're talking whether it's dogma or dog muck. I'm going to read you some statements, and you have to tell me whether you think it's true or false. So everyone's involved. No one's off the hook. Right, so here we go. First one. The majority of healthy people have a bowel movement every day. Is that science fact or science fiction, do you all think?
Fiction.
Fact?
Matt says fiction.
I think
Giles goes every day. And
on average.
actually, it's false. Only about 50% of the normal population poo daily. How often are you going then, do you think, Matt?
Well, I've just come back from a stag do, so several times. An hour at the moment.
Okay, question 2. Toxins accumulate in the intestine when bowel movements are infrequent. Is this true? Fact or fiction?
Well, I think we're coming back to the hangover poo here as well. But I would... It is a really good way of getting nasty stuff out, so I would say yes.
Speak for yourself, Kat. Eleanor? What do
I'd
you
say fiction. I'd
Charles?
go fiction.
I would say
Nutrition
fiction. I
man.
think your liver probably does most of the toxin removal.
Yeah, it's a fiction. There's no evidence that toxins accumulate when bowel movements are infrequent or that constipation actually leads
I'm
to
sucking
disease.
at this, I really am.
Okay, chronic constipation affects about half the population. Fact or fiction?
If half the population don't poo once again, I'm going to say fact.
Okay.
Well, I seem to be getting all of these wrong, so I'm going to go with Giles.
Fact. Matt?
Fiction.
Matt's pretty emphatic about that.
Yeah, I'm going to go for fiction as well.
Yeah, it's false. It is actually very common, though, being constipated. About 1 person in 5 is a sufferer
So
of
that's 20%.
regular constipation.
All
20%, yeah, right. Exercise fluids and the right foods prevent constipation. There you go.
But
Was that good?
that's what she says, our listener says, that she's exercising and she's eating
Well, that's the question I'm
brown.
asking you.
Yeah.
Is that true? Or is it a fiction?
Ooh. Well, clearly it's not working for her.
Yeah. Couldn't there be some kind of genetic predisposition or something, maybe?
Well, the answer is actually false, because those things do contribute, but actually psychology plays a very big role.
Really?
Also, medical conditions, Parkinson's disease, classically people who have Parkinson's often get problems, and also people with an underactive thyroid often get problems in that department, and people who use drugs such as codeine, so painkillers, they are very, very constipating. So how do you sort this out? Well, your bowel has as many nerve cells in it as your brain. In some people's cases, it has more nerves than your brain. So actually, it can learn. And when people talk about a bowel habit, this actually is very true. Your bowel learns your pattern of eating, and it learns when you tend to need to make space and ingest stuff, throw stuff down the toilet. So get into a habit is the advice. Go to the toilet regularly at the same time. But anything between once a day and about once a week is actually known to be compatible with good health. And most people think themselves into a state of worry when in fact they don't need to worry. So you're all right, Kat, you're okay. Now it says here, sorry Matt.
I would point out that if you are really struggling, strong German lager is also
this is
proven
Matt's
to be highly
evidence-based approach. The other thing they say is don't ignore the urge to go, because there are people and they're dubbed anally retentive for good reason, which is they're busy doing something else and they think, I won't go, I could go, but I won't go, I'm busy with this. And that's really bad, because what it does is it detunes your response of your gut, which it senses stretch and it knows when you need to go. And if you blunt that reflex, you're more likely then to store up trouble for yourself, quite literally. Also, reduce stress, because psychological distress actually can manifest in a range of ways, either going too often or not going enough. Drinking plenty of fluids does make a difference, because if you are really, really dehydrated, it can make things harder and harder to go. Also, increasing dietary fibre is a good idea, because that does have a pro-motility effect in some people. And don't abuse laxatives, because there are some people who think they've got something wrong, so they start taking lots of laxatives, and the laxatives make them go, but then they become laxative dependent. And it's a good idea not to do that, but to resort to other things. The thing that, to bottom line here, excuse the pun, is that it's not so much how often you go that's the problem, it's if something changes. And what doctors like me are interested in, not at parties, but if you come to seek my advice professionally, is we're asking you not how often do you go, but have you noticed any change? Because what's normal for you, we're all different. Everyone has their own sort of bowel habit, but it's when it changes all of a sudden, having previously been established, that's when we worry. So if being a little bit constipated is normal for you, consider some of these simple things that might help to improve matters, but don't panic unless something has suddenly changed.
The Naked Scientist getting to the bottom of all the important issues. So Rob has tweeted at Naked Scientist saying, how efficiently do we use the calories and nutrients in the foods we eat? Are all foods equal in what we get out of them? Giles, this is one for you.
It's a very good question. In essence, is every calorie a calorie? And from a physics point of view, clearly a calorie is a unit of energy. So every calorie is a calorie.
Can we just unpack what is a calorie?
Calorie is the amount of energy you need to raise 1 liter of water by 1 degree. Yep. That's correct. I'm getting the thumbs up.
So it's literally it's how much energy is in this particular amount of food. Right. So that's calories. So a calorie is a calorie or not a calorie?
A calorie is a calorie once you actually get access to it. It's all about caloric availability. Let me give you the example. 100 calories of sugar, which we're talking about, if you ate that, you would get 100 calories out of it because it's our base fuel. 100 calories of sweet corn. Now, anyone who's ever eaten sweet corn and given the topic of a conversation, had a peek down the next day, you can see that you do not digest 100 calories of sweet corn. If you take that sweet corn, however, and actually dry it up and pound it and make it into like a cornbread, then you get a lot more accessibility. So how you actually treat the calories, the type of calorie, and in what form it is, gives you different caloric availability, and therefore people think different calories differ, which they do from that perspective.
You're listening to The Naked Scientists with me, Chris Smith, and also with Kat Arney. This week we're answering your science questions, so if you have a question you would like us to answer for you, send them in and we'll put them in the bag for next time. It's chris@thenakedscientist.com.
Now, Matt, here's a question for you. Sandy has been casting her eyes to the skies and can't explain what she saw. So listen to this.
Is it possible to have two suns in the sky? My husband and I were in Norfolk, Vancouver area, and we both saw two suns. We asked if anyone else saw it, but no one did. We both know what we saw, but still don't know how to explain it.
What could be the explanation?
Aliens.
Okay, right. Next question, moving on.
When's my question on poo coming up? Right. Sandy, you're not mad. The scientific name for what you saw is parhelia. They're commonly referred to as sundogs. And the earliest reference I can find to this was from Aristotle, who died in 322 BC. So these have been documented for a very long time. I don't know why nobody else saw it. Perhaps they weren't looking at the right place in the sky. The reason that you see these things, it's refraction of light. We're all familiar with refraction of light. We've all seen rainbows. We probably, as a child, had a prism or something like, maybe cooler toys. Maybe my parents fobbed me off with something pretty weird. Cooler kids had
cooler toys than just prisms.
But essentially, it's refraction of light. So light bends as it enters a medium of a different density. What happens is, if it's very, very cold, you get crystals forming in the atmosphere, and they act as these prisms. So they bend the light rays as they pass them. So as these crystals float downwards, and the horizontal faces become more edge-on, you see the light refract horizontally. So you see them to the left and the right of the sun, and those are sundogs.
Eleanor?
How often does this happen? How have I been missing this?
Well, I don't think they've been missed. But you do have to have a certain combination of weather to actually get those. So again, it has to be quite cold. So you will see them quite often in winter. And it probably also helps that the sun is quite low on the horizon as well. So you do see them, but we just don't see them all that often. But the other thing to remember is that you're refracting light around. So those two mini suns won't be as bright as the main boy. So, they are a little bit fainter.
It's reassuring. Eleanor, Andrew has sent this in for us.
There are a lot of black bears where I live. I was wondering, do bears feel hibernation coming on slowly like we feel when we get sleepy at night? Or do they make a conscious decision and once in a suitable den, just switch it on?
Well, first of all, there hasn't been done a huge amount of studies on bears, unfortunately, on hibernation because of the difficulty of bothering a bear when it's trying to sleep. But there has been this great study being done on brown bears, and they found that, first of all, bears tend to just slow down a bit in autumn until it hits a specific time before the denning period in which they go into almost beginning to shut down, so they tend to move around really slowly. And they found that 50% of bears would start doing this while they were still quite a long way away from their den, and the other 50% would wait until they were close to the den to start doing this. It's difficult to tell because we obviously can't ask a bear, are you feeling sleepy? But this wind down suggests that, they're going into this sleepy phase. Also, the other interesting thing too is that apparently during this period, this is when brown bears are most dangerous. There's the greatest number of unfortunate encounters between brown bears and hikers because they reckon it could be that the bears are kind of sleepy, and they can't run away as well, so they tend to get a little bit more aggressive.
Charles?
An animal model which is being studied is a Siberian hamster. And what happened there is that you get a fluffy white Siberian hamster during the winter, and then they become lean and mean and thin during the summertime.
Hamster.
Absolutely.
Why are they mean?
to go after the acorn. But the critical thing, the critical thing is the scientists can induce changes in these animals just by changing the time of light. So if you go from 8 hours light to 16 hours dark, you will then have a winter hamster. And if you actually switch it around, you end up with a summer hamster. And so you're actually able to change this. I don't know if this is true for bears.
The light day length is the trigger for initiating whatever pathway kicks in to say you need to be thinking about going to bed now.
Correct.
That's so cool. With bears, they kind of found that they correlated with the amount of food present and what the temperature was. But I don't know whether if you put bears in a box and change their light patterns. I know with lizards
I'm sure
they
they'd be
do that.
delighted, Eleanor.
I know, exactly.
Sure they wouldn't mind at all.
Oh, well, you never know.
Well, if anyone's daring enough to try the experiment, do send in your findings to chris@thenakedscientist.com. OK, Kat, it's your turn. We've heard from Ned, and he wants to know, is there a link between diet and cancer? And specifically, he asks about vegan diets and allegedly lower rates of cancer in that group. Is that true?
So this is a really, really complicated question because unlike a behaviour like smoking or even drinking alcohol, everyone has a different diet. Everyone eats different amounts of food, all sorts of different types of food. It's different in different parts of the world. And as we heard earlier from Giles, like different people have different genetics and respond differently to the food that they eat. So it's really, really hard to unpick all of this. Now, there are a couple of massive studies that are going on. There's a huge study called EPIC, which is the European Prospective Investigation of Diet and Cancer. I know that Cancer Research UK is helping to fund a big part of that. And there's sites in Oxford and in Norfolk where they're looking at thousands of people. And in total, I think it's 500,000 people in Europe where they're saying, OK, what do you eat? How do you live? How does this affect your risk of cancer and of other diseases as well? They're looking at things like diabetes and heart disease. Now, there are a few broad brush things that EPIC has pulled out in terms of diet. So in terms of specific types of foods, it has shown that the more red meat and particularly the more processed meat you have in your diet, the higher your risk of certain types of cancer, and particularly bowel cancer is one of them. If you eat more fish, you have a lower risk of bowel cancer. If you eat more veg, more fibre in your diet, broadly that reduces your risk of certain types of cancer, particularly bowel cancer. And also there's a big part of just your overall body weight. So we know that the more obese you are, that does increase your risk of cancer too. The exact components of the diet and whether being specifically a vegetarian or a vegan is a lot more hard to unpick, particularly because in the studies, there aren't that many vegetarians and vegans. So one of the things we do know is that there seems to be a link between a particular growth factor, something called IGF or insulin-like growth factors, and your risk of cancer. That may be linked to animal products, may be linked to dairy. There's a lot of work trying to go on and unpick this. But you hear a lot of stuff about, oh, there are places in the world where they're completely vegan and they have no cancers at all. That's probably not true. The link between diet and cancer is very complex. But broadly, the main things we can say is the more fruit and veg you eat, the more fibre you eat, the less red and processed meat you eat. Fish is good, less alcohol is better. Those will broadly help to reduce your risk of cancer, as well as keeping physically active and trying to keep a healthy body weight.
What about smoked fish? Because I love that.
Oh, yeah.
I couldn't not have that.
So there's a couple of interesting things about, I think smoked
Because,
fish comes
someone
under
did write to me and they
processed.
said, Chris, I don't understand. Why is smoking bad for you if it cures salmon?
The cure for salmon. Yeah, I mean, certainly that comes under processing. We do know that, for example, particularly in Japan, where they have a lot of very salty food foods and a lot of pickles, that was, or certainly does seem to be associated with an increased risk of stomach cancers. And also, stomach cancer is really interesting because the rates of that, particularly in the West, have gone down massively because a lot of that is linked to gone-off food and the sort of nasty chemicals produced when your food goes off. And as everyone has a fridge now, you're much less exposed to those kind of nasties, and that's helped to reduce the risk, particularly of stomach cancer.
Napoleon had stomach cancer.
Wow, fascinating fact. I did not know that. But now it's my turn to grill you. So we've had a question from Zena, who asks, what research is available regarding varicose veins? Why do they happen, and can you prevent it?
Right, well, what is a varicose vein? This is common. About half of men and half of women are destined to get varicose veins. The evidence is women will get them slightly younger than men. They are bulges or dilatations in the veins, often seen in the legs. And the reason for this is that the pressure is greatest in the veins in your longest part of your body, in your dependent tissues. So if you imagine yourself standing up, you've got all of the mass of the blood in that column of blood vessel, which goes from your big toe right the way back up to your heart, pushing down on your veins. Veins aid the return of blood to the heart because they have valves in them, and those valves allow one-way flow, and every time you contract a muscle you squeeze the vein, and this applies a pressure to the blood and it pushes blood through the valve and it moves it back up to the heart. Now eventually some of those valves fail a bit, and so instead of there being a short segment of water pressure pushing down on each segment of the vein, you can end up with a long column of water pushing all the way down on one bit at the bottom of the vein. And so the pressure on the wall of that vein can become quite high, and it leads to that segment of the vein beginning to stretch or dilate and becoming tortuous. And you often see this happening on the lower limb because that's where the pressure's highest. We know that they tend to be more common in people who gain weight. We know that pregnancy is a risk factor, probably because you gain a bit of weight, but you also have more pressure on your venous system. We also know that family history seems to play a role. If you have a family history of people getting varicose veins, especially at a younger age, you are more likely to succumb to them yourself, but that's not a given. How can we treat them? Well, you can stop them happening in the first place up to a point if you minimise your risk factors. You can minimise your body mass index, which is a big risk. Sorry, Kat.
Does putting your feet up a lot help?
It doesn't really seem to, no. There's not really any evidence that being lazy does help, probably because you gain weight, and so one thing begets the other. The other thing you can do, though, is have surgery. And what you do is a strip of the vein, and it looks pretty nasty, and it is pretty nasty. What you do, and I've done this operation, you take someone, hopefully anaesthetised and asleep. It would be very painful if you didn't have them asleep. You thread a cannula up from the bottom of the vein right up to where it joins the vein at the top of the leg, and it's got a big bulge on the end of this cannula, this big thing. It looks a bit like a mini torpedo. And once it's come out of the end of the vein, you then yank back and strip out the whole of the vein all the way back along its course and rip it all out. And you rely on the blood then finding other routes back up inside the body. And that's called a stripping. And also the little ones, the little perforators, you do a multiple sort of stab. You stab through the skin and whip them out, and they just thrombose off. So that's how you stop them. If they are a big problem, you don't have to resort to surgery. What some people sometimes do is wear those stockings, those what are called TED or thromboembolic deterrent stockings, which are elastic stockings, and they apply pressure across the wall of the vein, stopping the vein stretching and dilating. But unfortunately, not everything improves with age, and your risk of varicose veins is one of them. Sorry, Kat.
Oh, sad, isn't it? Anyway, moving to slightly more cheerful, perhaps less cheerful topic. Here's one for you, Giles. Stephanie says, I have a question about intolerance to dairy and alcohol. She's read that the gene for digesting dairy products is on chromosome 2, whilst the gene for metabolising alcohol is on chromosome 12. If these aren't linked, so they're not genetically linked, they're not on the same chromosome, why do both of these intolerances often tend to occur simultaneously? And how do you diagnose an intolerance?
They're not linked genetically, and their apparent linkage in the world in various, ethnicities is entirely coincidental. And it actually has to do with the history of agriculture within that particular region. So milk, most of the world cannot handle milk. People don't know this. So most people are actually lactose intolerant or are unable to handle lactose once they become adults. The reason why the ability to lactose has evolved is because three different populations in particular, Northern Europeans and two different African tribes, figured out that if you don't kill the cow or the camel or the goat immediately and eat the meat, but drink the milk, you actually get a lot more calories out of them. That's the first thing. The second thing is milk provides a very safe drinking source. And so for people who are able to take advantage of this, they thrived. You might ask why a lot of the world are not able to handle milk. I'm Chinese, so I'll use the Chinese example. And the reason why is because they had their own other sources of calories. And the Chinese, for example, were the first people to domesticate chickens. And so then chickens came with eggs, and they were able to do that. And the Chinese were the first to domesticate pigs, and we don't drink pig milk egg. So therefore they do that.
I thought you were going to say they were the first to come up with crispy duck as well. 'Cause I mean, that is also fantastic.
Poultry, all in general. In terms of alcohol, once again, post-agriculture, and people were able to drink it, and people have always drunk it for cultural reasons. The reason why some cultures are able to handle it more than others, however, has to do with safe drinking water. So the Northern Europeans and the people in the Fertile Crescent, so the Middle East, chose to purify their water by adding alcohol, and so that it was then became safer to drink.
Good choice.
And so they had to be able to metabolize it well enough to drink it, otherwise they would die. The Chinese, amongst other groups, chose to boil it and then the water and end up sticking some twigs in it and called it tea. And so although they did drink alcohol, their survival did not rely on alcohol.
So those genetic variations for lactose tolerance and alcohol tolerance have just become selected in the populations that have loads of dairy and loads of booze.
Correct.
A slightly more macabre question here from Michelle Eleanor, who wants to know, I would like to know where birds go to die. The only dead birds I've seen are from roadkill, a cat or a dog's kill, or a baby bird that's fallen out of the nest.
There isn't a place where birds go to die. There isn't like a bird graveyard somewhere. But birds tend to get carried off after they die quite quickly. There was an experiment done in which they put 275 baby chicken chicks who had been killed. They left 275 of these out in the field, and then they came back the next day to check on them. 24 hours later, they could only find 2 baby chicks left. And the rest of them had been carried off by various scavengers, birds, cats, dogs, or whatever other animals happen to be in the area. So it could just be that we have an amazing ecosystem with so many awesome scavengers that just take them off to a better place quite quickly.
It's a nice thought, isn't
I know.
it? Takes them off to a better place, like their stomach.
Yeah, exactly.
I think one of the most incredible bits of bird behaviour I ever saw, I live pretty close to the centre of London, and I saw a sparrowhawk bringing down a sparrow in my back garden.
Oh my goodness, that must be
and
amazing.
they pluck it in this beautiful circle of feathers and then eat it. And then it was just gone, but all there was left was this perfect circle of feathers.
It's The Naked Scientist with me, Chris Smith.
And with me, Kat Arney. It's our Q&A show today, so if you'd like us to answer your science questions, anything from why bees buzz to why stones sink but wood floats, then ping us an email. It's chris@thenakedscientist.com, and we'll do our best to answer them next time round.
Now, we got this question for you, Matt. We heard from Vishal, who sent this in.
If I was falling into a black hole, and if I were to survive for long enough, would I be able to see the end of the universe approaching, however that may look?
This is a great question again. So there's this very, very well proven theory that if you are closer to a gravitational body, time would, for you, appear to be, from an outside observer, would appear to slow down. And we know this because if you put an atomic clock in orbit, it actually runs faster. So because it's further away from the gravitational potential, it's called, it's an effect of gravitational time dilation. It's really stunning. So in fact, if you're orbiting on the ISS, time is running actually a bit faster.
Do you get that time back when you come back down to Earth?
Well, time is all relative. So for you, time is just your time. Okay, it doesn't feel any different for you, but essentially you only have those seconds to live, right? So I don't scare you, Kat.
I have
you
seconds
only have
to live.
seconds to live.
Yeah.
She has got 9 lives.
Oh, right. That's so
Brilliant.
razor sharp. So this is a great idea then, that if you were falling towards a black hole, which is a very, very deep gravitational potential well, if we were watching them, we'd see them slow down, slow down, slow down. If we had a clock, the clock would get slower and slower and slower until it went to the event horizon, and then it would fade out of our ability to see it, because at the event horizon, which is the point where not even light can escape from the gravitational well, that's it. That's the cutoff for being able to see it, obviously, because light can't escape. So this idea then would be that, I'm near a black hole and time, everything else seems to be going faster and faster and faster. Maybe I can see the end of the universe. Great idea. The thing is, you have to basically prevent yourself from crossing the event horizon, because once you do that, you're on a one-way trip to the singularity to be compressed down to something unpleasant. So you have to be able to hold yourself at the event horizon or just above the event horizon. And then in principle, yeah, you could see the universe speeding up and whatever that would look like. What it would actually look like would be a complete, blow your mind probably.
And the bigger the black hole is, the faster the more dramatic that time dilation effect will be.
Absolutely, yeah.
Well, look, Alex has asked the following.
I currently work in the public sector, but learned later in life that my real passion is in the sciences. I'm considering re-entering university to pursue a science degree. In all of the science podcasts and media I consume, I don't hear much about people entering sciences as a second career. Is this a realistic goal? If so, would you have any recommendations?
This is a fantastic question. I'm really like, yeah, go Alex, do science. Unfortunately, Alex hasn't really specified what kind of science. We've got kind of 5 scientists in the room here. We've got a medical doctor, I'm a geneticist, we've got an animal behaviourist, an astrophysicist, and someone studying metabolism and human diseases and disorders. So there's a lot of science in the world. So it kind of depends on, I think, what particular type of science. But there are, I guess it's never too late. There's nothing to stop you. Giles, what do you think?
I'm a fellow at Wolfson College here in Cambridge, and it's a mature students' college. So although we have a lot of graduate students, and those are people coming in and doing PhDs, we also have a contingent of undergraduate students that are older. And all of them have come in from second careers. Not all to do science, perhaps, but to do medicine, to do archaeology, and any number of other degrees that you just decided that you had a change in mind to do. And I would say probably 20% of them are coming in to do science. And these are people who were lawyers before, who were, any other, types of careers. So definitely not impossible. There are colleges, even in Cambridgeshire, which specialize, that try and develop you for your second career, including science.
What do you reckon, Matt? I mean, if someone, for example, particularly I always feel to go into physics, you've got to have really good maths.
You absolutely do, Kat. You're right. I mean, yes, Alex, go for it. Absolutely. Follow your heart, your dreams, and whatever. Lots of good platitudes. But absolutely, don't give up on that. But it is tricky. I mean, you shouldn't for a second think that this is something that anybody, I'm just a drop of a hat. I'm no longer going to be a lawyer. I'm no longer going to be an accountant. I'm going to be something else entirely. You do have to, it's good to have some transferable skills like maths, certainly for physics. And the other thing to keep in mind is that if you do want to follow an academic track, and I hate to be the bearer of bad news, but if you want to get to the end and have tenure or a lectureship or something like that, they do actually care a little bit about your age. Some places want younger departments moving forward that they can then mould. So if you're going to be a lecturer for sort of 5 years before you retire, that isn't always seen in a great light. But that should not stop you at all.
I also think it's important just that we have more people who are literate in science broadly. I mean, really briefly, Eleanor, what would be your advice?
I'd say go for it. I think it's super exciting. I'd say if you're still wondering which kind of science you want, then try it out. There's lots of places that do internships or experiences that you would be able to get in touch with people.
And there's always the Open University as well.
Well, that's it for this week. Thank you to our wonderful guests, including Matt Middleton, Giles Yeo and Eleanor Drinkwater, and Greer Jackson for production. Next time, 100 years have gone by since cocaine was made illegal. The Naked Scientists are going to be getting high on the science of drugs. And just in case you're terminally disappointed that you didn't hear what a farting fish sounds like, we've got the sound just for you. And on that note, The Naked Scientist comes to you from Cambridge University and is supported by the STFC, the EPSRC and Rolls-Royce. Thank you for listening, and until next time, goodbye!